When derating wires for conduit fill, it's essential to determine if the neutral conductor needs to be counted as a current-carrying conductor. The National Electrical Code, or NEC, provides guidelines on this matter. Generally, a neutral conductor is only counted as a current-carrying conductor when it carries significant current. This typically occurs in situations with nonlinear loads, such as those found with electronic devices and lighting systems that generate harmonic currents. In a three-phase, four-wire system, if the major portion of the load consists of nonlinear loads, the neutral conductor must be counted as a current-carrying conductor. This is because the harmonic currents, particularly the third harmonic and its multiples, can add up in the neutral conductor. The increased current in the neutral conductor can cause overheating if not properly accounted for in the ampacity calculations. The NEC addresses this in articles like 310.15. If the neutral conductor only carries the unbalanced current from a balanced load, it typically does not need to be counted as a current-carrying conductor for derating purposes. A balanced load is one where the current in each phase is approximately equal. In this scenario, the neutral current is minimal. However, the specific requirements depend on the application and the nature of the loads connected to the circuit. When bundling conductors in a conduit, the ampacity of the conductors must be derated according to NEC tables such as Table 310.15b3. This table provides adjustment factors based on the number of current-carrying conductors in the conduit. These adjustment factors reduce the allowable ampacity of the conductors to prevent overheating due to the combined heat generated by the conductors. To determine whether the neutral conductor should be counted, consider the type of loads connected. Nonlinear loads, such as LED drivers, electronic ballasts, and computer power supplies, produce harmonic currents. These harmonic currents can significantly increase the current in the neutral conductor, necessitating it to be counted as a current-carrying conductor. If the loads are primarily linear, such as incandescent lighting or resistive heating, the neutral conductor typically does not need to be counted unless it carries a substantial unbalanced current. The NEC defines a neutral conductor as a current-carrying conductor when it carries current under normal operating conditions. This definition is crucial for understanding when to include the neutral conductor in ampacity derating calculations. Ignoring the neutral conductor when it should be counted can lead to undersized conductors, resulting in overheating, insulation damage, and potentially fire hazards. Therefore, a thorough assessment of the loads connected to the circuit is essential. In summary, when derating conductors for conduit fill, you must count the neutral conductor as a current-carrying conductor if it carries significant current due to nonlinear loads or substantial unbalanced current. Always refer to the latest edition of the NEC and consult with a qualified electrical engineer or inspector to ensure compliance and safety. To provide a more detailed explanation, let's delve into the specifics of calculating conductor ampacity and applying derating factors based on the number of current-carrying conductors in a conduit. Ampacity is the maximum current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by factors such as the conductor material, size, insulation type, and ambient temperature. The NEC provides ampacity tables, such as Table 310.16, which list the allowable ampacities of various conductors based on these factors. When multiple conductors are installed in a conduit, the heat generated by each conductor can raise the overall temperature within the conduit. This increased temperature can reduce the ability of the conductors to dissipate heat, leading to a decrease in their ampacity. To account for this effect, the NEC requires that the ampacity of the conductors be derated based on the number of current-carrying conductors in the conduit. The derating factors are provided in Table 310.15b3 of the NEC. This table lists adjustment factors that must be applied to the ampacity of the conductors based on the number of current-carrying conductors. For example, if there are 4 to 6 current-carrying conductors in a conduit, the ampacity of each conductor must be reduced to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced to 70%, and so on. To accurately apply these derating factors, it is essential to correctly identify the number of current-carrying conductors in the conduit. This includes not only the phase conductors but also the neutral conductor if it meets the criteria for being counted as a current carrying conductor. As previously mentioned, the neutral conductor must be counted if it carries significant current due to nonlinear loads or substantial unbalanced current. Nonlinear loads, such as electronic devices and lighting systems, generate harmonic currents that can significantly increase the current in the neutral conductor. These harmonic currents are typically odd multiples of the fundamental frequency, such as the third, fifth, and seventh harmonics. In a three-phase, four-wire system, the third harmonic currents from each phase can add up in the neutral conductor, resulting in a neutral current that is significantly higher than the unbalanced current from a balanced load. The NEC requires that the neutral conductor be counted as a current carrying conductor when the major portion of the load consists of nonlinear loads. This is to ensure that the conductors are properly sized to handle the increased current in the neutral conductor and to prevent overheating. To determine whether the neutral conductor should be counted, it is necessary to analyze the loads connected to the circuit and determine the percentage of nonlinear loads. If the percentage of nonlinear loads is significant, the neutral conductor should be counted as a current carrying conductor. In addition to nonlinear loads, a neutral conductor must also be counted as a current carrying conductor if it carries a substantial unbalanced current. An unbalanced current occurs when the current in each phase of a three-phase system is not equal. This can happen when the loads connected to each phase are not balanced. In this scenario, the neutral conductor will carry the difference between the currents in each phase. If this unbalanced current is significant, the neutral conductor must be counted as a current carrying conductor. To determine whether the unbalanced current is significant, it is necessary to measure the current in each phase and calculate the difference. If the difference is significant, the neutral conductor should be counted as a current carrying conductor. Once the number of current carrying conductors has been determined, the appropriate Derating factors can be applied to the ampacity of the conductors. This will ensure that the conductors are properly sized to handle the expected current and to prevent overheating. In addition to Derating for conduit fill, it is also important to consider other factors that can affect the ampacity of conductors, such as ambient temperature and conductor bundling. The NEC provides guidelines for Derating conductors based on these factors as well. To further clarify the concept, let's consider a practical example. Suppose we have a three-phase, four-wire system with a 20 amp circuit breaker and three-phase conductors and one neutral conductor in a conduit. The load consists of both linear and non-linear loads. After analyzing the loads, we determine that the non-linear loads account for a significant portion of the total load, meaning that the neutral conductor should be counted as a current carrying conductor. Therefore, we have four current carrying conductors in the conduit. According to Table 310.15b3 of the NEC, the ampacity of the conductors must be reduced to 80% of their original value. If the conductors are rated for 30 amps at their normal temperature rating before derating, then the derated ampacity would be 30 amps multiplied by 0.8, which equals 24 amps. Thus, the conductors are adequately sized for the 20 amp circuit breaker. However, if the neutral conductor did not need to be counted as a current carrying conductor, then we would only have three current carrying conductors. In this case, no derating would be required, and the conductors would be more than adequately sized. In conclusion, when derating wires for conduit fill, it is essential to determine whether the neutral conductor should be counted as a current carrying conductor. This determination depends on the type of loads connected to the circuit and the amount of current carried by the neutral conductor. If the neutral conductor carries significant current due to nonlinear loads or substantial unbalanced current, it must be counted as a current carrying conductor. Ignoring the neutral conductor when it should be counted can lead to undersized conductors, overheating, and potentially fire hazards. Always refer to the latest edition of the NEC and consult with a qualified electrical engineer or inspector to ensure compliance and safety. Additionally, consider factors such as ambient temperature, conductor bundling, and voltage drop when selecting conductors for an electrical installation. Remember that proper conductor sizing and derating are crucial for ensuring the safety and reliability of electrical systems. Proper planning, calculation, and installation practices can prevent electrical hazards and ensure the longevity of the electrical system. Finally, always use appropriately rated tools and personal protective equipment when working with electrical circuits and conductors. Safety should always be the top priority in any electrical work.